45. What you want to do in a problem like this is get your logs together on one side. So you're gathering your logs on one side. So add log x base 6 over to the left. And that's equal to 2. Okay? So once the logs are gathered, do they have the same base? Yes. So you can apply that quotient rule, the product rule, right? The product rule, which states that if two things are being added, what can you do with their arguments? Multiply them. So ask yourself at this time, if I rewrite this as an exponential equation, 6 to the 2 equals the stuff in the middle, could I then solve it? 6 to the 2 equals this stuff. Can I handle solving a problem like this? I think you can. It's a quadratic. You should know how to do this by now. Get 0 on one side, and then hope that you can use the quadratic formula. No. Hope that you can factor it. Can you? You need something times something to make 36, and then that needs to add up to -1 in the middle. What number was this, 45? I think you might want to use the quadratic formula. Or, oh no, here we go. Because look, one of them has to be 2x, and the other one is x. I think this one does work out. I remember this from yesterday. So we have 2x minus 9, and then x plus 4. That is one of the, somebody gave us that as their candidate for being right. Is that 2x squared? Yep. What do you get on the outside here? You get on the inside. -9x. Is that going to make my -1x in the middle? Yes. And then -9 times 4 makes the -36. So that looks good. All right? The two solutions now come from setting each factor equal to 0. This one's easier. X would have to be -4 for that to equal 0. Some people can think about the other one and get the answer. I think it's 4.5, right? Because double 4.5, you get 9. 9 minus 9 is 0. If you can't do that math in your head, set it equal to 0 and solve. 4.5, or 9/2. So one of these is a valid answer because in the original problem you were supposed to do a log, right? If I put -4 in for x in the original problem, it would be extraneous. So you got to throw this one out. This is the only valid answer.